Alright, this is question 4 on the 2011 Form B test. Part A says find the x-coordinate of the critical point of f. So if we have a function f, its critical values are found when we take the derivative of f and set it equal to 0 or set it equal to undefined. This is the derivative, so all I want to do is figure out when f prime of x equals 0 or f prime of x is undefined. So, yeah, you know what I mean. Okay, so I look at this and I've got f prime of x equals 4 minus x, and really if you think about it, times x to the negative third is really just x cubed on the denominator. So this is pretty easy to answer. When is it going to equal 0? When x equals 4, or when's it going to be undefined? When x equals 0. Except you go back and it says this is only for x greater than or equal to 0, so we don't need that. X equals 4 is what I'm looking for. So I make a sign chart. 0, not going to look over here, to 4, and then above 4. So I plug in a number like 1, and I get 4 minus 1 over, that's going to be positive. I put a number like 10, and I get negative on top, so I'm going to get negative. Determine whether the point is a relative max, a relative min, or neither. Justify my answer. Okay, so we can see it goes from positive to negative at 4. So x equals 4 is a maximum because the slopes of f are positive for x less than 4 greater than 0, and then the slopes are negative for x greater than 4. Alright, x equals 4 is a maximum because the slopes of fx are positive between 0 to 4, and the slopes are negative bigger than 4. I could have also talked about the derivative being positive or negative. Either way, the justification should be fine. Alright, did I answer all the questions? Looks like it. Part B. Find all the intervals on which the graph is concave down. Justify my answer. So, again, I think I prefer it written this way. And so I need to find the second derivative. So I do quotient rule. Derivative of the top is negative 1 times the bottom minus the top. Oops, no cube there. Times the derivative of the bottom, which is going to be 3x squared all over x cubed squared, which is x to the 6th. So I get negative x cubed minus 12x squared plus, because I've got to distribute this minus sign, 3x cubed. So that's going to give me 2x cubed minus 12x squared over x to the 6th, which I can factor out an x squared out of the top and reduce with the denominator. So I should get 2x minus 12 okay, so there's my second derivative. So now I got to find out where it's positive or negative. So I take a look at this. Again, we're only looking for x greater than 0. And 0 would be a point that we'd need to check for a point of inflection. But 0 is not part of the region they want me to look in. So that means the only place where I have a inflection point is when the second derivative of x equals 0, add 12 divided by 2, x equals 6. Alright, so now I'm going to make a sign chart. It's getting a little messy here, I'm sorry. 0, nothing over here, up to 6. So now I'm going to plug in a number like 1, and I get a negative over a positive. Plug in a number like 10, and I get a positive over a positive. So find all the intervals where it's concave down. Well, unless I've made a horrible mistake, I think that's my answer. So f of x is concave down from 0 to 6 because second derivative of f is less than 0. Alright. And part C. Alright, find f given an initial value. So f of 1 equals 2. F prime of x is 4 minus x over x cubed. Okay, so I need to find the antiderivative which will give me a plus c, and then I can solve for c. Okay, so you might think about doing a substitution because we've got this x cubed and this 4 minus x, but really the best thing you should do is you should actually divide both of the terms by x cubed. So that gives me the integral of 4 over x cubed minus the integral x over x cubed is going to reduce to 1 over x squared. So I'm just going to do these separately and put a plus c on. Okay, so what are we going to have here? We're getting super messy now. So this is really x to the negative 3. So I'm going to add 1. I get x to the negative 2. I got to account for the negative 2 canceling out, so I got to multiply by negative 1/2. But I already have a 4 there, so it looks like I get negative 2. Check it. Negative 2 comes down, makes positive 4, x to the negative 3. That's what we've got. Minus 1 over x squared is going to be x to the negative 1 and a negative. So let's test it. Negative comes down, turns my positive into a negative, which is what I want. And the x goes to negative 2, which is what I want. Plus c. So this is the function f. I have an initial value of 1, 2. So I plug it in, I get negative 2, and then 1 is here. X is 1 to the negative 2 is just 1. Plug in 1 to the negative 1 is just 1, plus c equals 2. So it looks like I'm going to add 2 and subtract 1. So it looks like c equals 3. And the actual function then is, running out of room. It's really late at night, by the way, which is why my voice might be a little bit monotone today. Sorry about that. Okay, let's rewrite f with the plus c plugged in. So I get negative 2 over x squared plus 1 over x plus 3 equals f of x. make sure we answered the question. Given that, find f. Alright, I think we have. For such an easy question, I sure have written a lot. Let's quickly check our answers. Alright. Part A. F prime of x equals 0 at x equals 4. F of x is greater than 0 from 0 to 4. And x is less than 0. Therefore, it has a maximum. Looks good. 3 points for that. Part B. Where is it concave down? So we got to take the second derivative. And the graph of f is concave down in the interval from 0 to 6. And because right here they said the derivative is less than, second derivative less than 0 between 0 to 6. And then we have part C. And let's just cut to the end here. Oh, I need this one. Alright, 3, yeah, minus 2x, yep. There you go, 3 more points. 1 for the integral, 1 for the antiderivative, and then 1 for your answer. Okay, that ends video number, what is this, 3, 4? I don't know. Moving on to the next one.